Hi guys, today let us study another numerical based on the concept of wedge friction. Well, a body of weight 200 kN is to be raised by means of the same wedges A and B. Find the force P for impending motion of block C upwards if the coefficient of friction is 0.2 for all the contact surfaces. Neglect the weight of the wedge. Well, hence, here they have given us that a body weighing 200 kN is to be raised upward by the horizontal movement of the two wedges. Hence, we have to find the horizontal force P, which will impede the motion of the block C upwards. Now, we can see that the figure is symmetrical about the vertical axis. The figure is same if a midline vertical axis is drawn. Hence, the wedges will move the body upwards due to its inward motion. Now, consider the free body diagram of the body. Hence, this is the FVD of the body where the weight of the body 200 kN acts downwards, and also the reaction forces R1 and RB acts at point A and B due to the contact surface, due to the contact of the body with the two wedges. Consider the free body diagram of the body. Here, there will be two frictional forces acting on the two inclined sides, that is point 2 R1 and point 2 R1, which will be in the direction opposite to that of the motion. Also, a normal reaction force will be acting at points A and B, that is R1 and R2, making an angle of 16 degrees with the vertical axis, as in the given this angle to be 16 degrees, and hence a vertical axis drawn to the point of the reaction force will have the same angle. Now, summation V is equal to 0, hence minus 2000 plus 2 times R1 cos 16 minus 2 times 0.2 R1 sin 16, as the figure is symmetrical about the vertical axis. On both the sides, the forces will be same. Hence, minus 200 plus 1.81 R1 is equal to 0. Hence, R1 is equal to 200 divided by 1.81, which means R1 will be equal to 110.5 kN. Now, consider the free body diagram of the wedge. Well, a frictional force will be acting in the direction opposite to that of the motion of the wedges, that will be 0.2 R2, a normal reaction R2 to the wedge, and also a frictional force which will be opposing the inclined movement of the wedges, that is 0.2 R1 in the opposite direction to that of the motion, and a reaction force which will act at an angle of 16 degrees with the vertical axis. Hence, now summation V is equal to 0. Hence, R2 minus R1 cos 16 plus 0.2 R1 sin 16 will be equal to 0. Hence, R2 minus R1, that is 110.5 cos 16 plus 0.2 R1, that is 110.5 into sin 16 will be 0. Hence, the value of R2 will be 100.13 kN. Now, summation of the horizontal forces will also be equal to 0. Hence, P minus 0.2 R2 minus R1 sin 16 minus 0.2 R1 cos 16 will be equal to 0. Hence, P minus 0.2 into R2, that is 100.13, minus R1, that is 110.5 sin 16, minus 0.2 into R1 cos 16, that is 110.5 into cos 16 will be 0. Hence, the value of P will turn out to be 73.73 kN. Thank you.
Wow, that's impressive! You have completed a magic today. For more videos, subscribe. Join our Facebook group and Instagram page for group discussion and live magazine videos for exam preparation in an hour. We start at ClassFly community for students to learn from a friend in a simple way and support them in their own languages. If you are willing to be that one friend who saves us at the exam night preparation, then please join us by visiting classfly.in.